All right, in 7.6, we're going to continue on with our discussion about confidence intervals for means, estimating means. So what do you do when you're trying to show that it's normal in shape, but your sample size is less than 30, and you don't know what the population distribution is? You don't know if it's normal in shape. They don't tell you. So this is the what ifs. What if you don't know those two things? Well, let's just revisit. There's 3 ways we can know, right? You can know that the data came from a normal distribution, the sample size is greater than or equal to 30, or here's the new thing. When the sample size is small and the shape of the population distribution is unknown, here's what you do. You graph the sample data and you look for strong skewness, means really obvious, or outliers. Remember, outliers are points that just kind of are out there by themselves. Okay, so my recommendation is just to do a box plot. So if there's a box plot, looks something like this, that's approximately normal. But if you had outliers out there, then that would be a problem. Okay, so you're looking to see that there's no outliers and that it's approximately normal. Doesn't have to be perfect, just can't be strongly skewed. All right. So if that's the situation in the problem you're doing, you have to include a graph, and I'll remind you how to do that with your calculator. It doesn't matter if you use dot plot, stem plot, a histogram, or a box plot. You just have to check. So if you're more comfortable just drawing a dot plot of the data, then go with that. If you want to do the box plot, like I show you how in the calculator, you can do that as well. Either one really doesn't matter. Any of these types will work. All right, so when you're constructing and interpreting a confidence interval, you're going to follow the 4-step process. Same thing we use with proportions. State, plan, do, conclude. All right, same exact steps, just a different parameter. We're doing means this time. Okay, we'll walk through the example together. So pause the video, fill this out. All right, just revisiting. What does our formula look like for the confidence interval of means? Well, here it is. X bar, our sample mean, plus or minus T star. The sample standard deviation divided by the square root of the sample size. And remember, for T star, we have to know what degrees of freedom is, and so we use n minus 1 for that. So let's try the first problem. Judy's interested in estimating the reading level of a medical journal using an average word length. She records the length of a random sample of 100 words. The histogram shows the data. Determine if the normal large sample condition is met. Well, look at the graph. Hopefully, you look at this and you're like, oh, this is not normal in shape at all. It's not. You're right. Remember, this is more of a right skewed shape. So the skewness will not work for us. But look at the sample size. It's 100. So you can say, yes, this is normal. Because n, which is 100, is greater than or equal to 30, and we can use the central limit theorem. That's all you have to tell me. Okay? The skewness of the graph doesn't matter if you pick a big enough sample size. It's okay. All right? If the sample size was like 19 and it looked like this, you can't say it's normal because it is strongly skewed. All right? So the first few problems in your homework, you're going to be given a similar situation. You want to look for outliers. Remember, outliers in the histogram look like this, but they look like little boxes over on the right by themselves. So if there's outliers, you can't say it's normal. If it's strongly skewed, you can't say it's normal. So look at the graph if you need to. All right, number 2 here. This is the whole state plan to conclude process, all right? So I'm going to put it on 2 slides because we'll need some space. But here's the scenario. Several years ago, the U.S. Agency for International Development provided 238,300 metric tons of corn-soy blend for emergency relief at countries throughout the world. CSB is a highly nutritious, low-cost fortified food. As a result of a study to evaluate appropriate vitamin C levels in this food, measurements were taken on samples of CSB produced in a factory. The following data are the amounts of vitamin C measured in milligrams per 100 grams of blend. for a random sample of size 8 from one population run. Construct and interpret a 95% confidence interval for the mu, the mean amount of vitamin C in CSV from the production run. All right, so we have a very small sample size. All right, for state, let's do this, okay? Since we want to estimate your phrase right out of the thing. Here it is, the mean amount of vitamin C in CSV in this production run. That's what we want to estimate, and with what level of confidence. With this 95%. So remember, you have to tell me what it is I'm estimating and with the level of confidence, fully in context. Okay, so on our plan step, we need to explain what we're going to do. We're going to do a one sample t interval. All right, and then I check our conditions. So random, we know this is a random sample where n is equal to 8, so that condition is good. And the second thing is it normal? Okay, well, n is less than 30, so we had to do a dot plot. So I drew a dot plot. You need to draw this in your notes. And really, there's no major skewness here, and there's no major outliers. Really, between 10 and 30, that's not a huge gap, but it has to be a strong skewness or outliers. So this one is considered not strong skewness, nor does it have outliers. So you would say no strong skewness or outliers. That's how you defend your dot plot. Don't just put a dot plot and not a statement. You need to have both parts. Okay, so that's the state. This is the plan. Now let's do this interval. All right, so to do this in your calculator, remember our formula. It's going to be x bar plus or minus t star times s over the square root of n, right? Well, we need to put our data in a list in the calculator for this to work. So we're going to pull up our calculator, and if you remember, you're going to go to stat edit, and if there's something in list 1, go up and clear it out and enter this data. So we get 26. All right, so that data is nicely in there. Watch this. We're gonna go to our data's in there. So if we go to stat over to test and go down to 8, we know it's a t interval because it's mean. Now remember we said you could use the data. If you click on data, it's gonna say, okay, where's the data? Well, we just put it in list 1, right? So it's gonna find x bar from that list, and it's gonna find the standard deviation from that list for us. Okay, we're gonna need to write it in our formula, but the calculator is going to do it for us. All we need to do at this point right here is adjust our confidence level. We were trying to find a 95% confidence level, so we're going to leave it like that. Now, if I come down to calculate, notice what it gives me on my output. There's my confidence interval, but there's my x bar, and there's the standard deviation of that data. It does it all in one click. All right, so the work that you need to show me needs to have the x bar, the s value, and the t star. So you're going to have to go back and find t star, although the calculator already did it. I get that, but you already have your answer. So I'm going to move my calculator so I can write this down for you. So x bar was 21.29 plus or minus. Going to leave space for t star. S was 6.82 divided by the square root of 8. And it gave me the interval 14.97 to... Now let's back up for a minute. Let's figure out what is t star for a 95% confidence. So we know that spot right there is 0.025, so I go to inverse t. The area is 0.025 degrees of freedom on this guy. Remember, it's 8 minus 1, so it's just a 7. So if I put that in my calculator, number 4, 5, I need to change my degrees of freedom to 7. So I'm going to use a t-star value of 2.3. So that's what goes in here. So just like before, I need to see the formula written out with your numbers. I need to see the answer. Now, we conclude like we always do. We're going to start with, we are 95% confident that the true, remember, go back and reference the stem of the problem, the true mean amount of vitamin C and CSB from this production run. All of that goes in your conclusion. Is between, and then I put our values in, 14.97. What was our unit? Remember, it was milligrams per 100 grams and 27.6 milligrams per 100 grams. All right, so it is a longer process. I mean, it is a long process, all 4 steps, but you can do this. Very, very easy. You can do it. Good luck, and we'll see you in class.